All right, good morning, everyone. Thank you for joining our webinar today. For your information, this webinar is being recorded and will be made publicly available on the RemPlex webpage for archive. And just as a reminder, we request that you please keep yourself muted during the presentation and Q&A. My name is Alicia Gorton with Pacific Northwest National Laboratory, or PNNL, and I'll be moderating today's webinar. And today's presentation is going to showcase a new platform launched by Pacific Northwest National Laboratory called the Center for the Remediation of Complex Sites, or RemPlex, that couples unique core competencies and expertise with state-of-the-art facilities and physical assets to develop, mature, and deploy advanced technologies to solve complex issues of contaminated subsurface environments. RemPlex Director Dawn Wellman will present how RemPlex fosters technical stewardship and advances the R&D needed to translate science and engineering innovation into practical, adaptive, and operational solutions to address complex site remediation. Dr. Wellman serves as the Director of the Earth System Science Division in the Energy and Environment Directorate at PNNL, where she previously served as manager of the environmental health and remediation market sector. She is an industry leader in developing and implementing systems-based approaches for characterizing, monitoring, and remediating contaminated groundwater and soil sites throughout the U.S. Department of Energy complex, as well as internationally. After the presentation, I encourage you to submit any questions you have via the chat box, which will be monitored. And those questions will be passed along to Dawn and others on the RemPlex leadership team to discuss. So with that, I'll turn it over to Dawn to introduce the Center for the Remediation of Complex Sites. Dawn?
Thank you, Alicia. I appreciate that introduction. And thank you, everybody, for joining us today. It's a Friday afternoon, and I know in the world that we work in today, we seem to have innumerable webinars that we can partake in. So I really appreciate you joining us today to find out more about our Center for Remediation of Complex Sites. We're very excited to be able to launch this center. PNNL has been a leader in environmental remediation since 1965. And with a proven track record of over 50 years of supporting our industry partners and our federal sponsors in addressing environmental remediation challenges, we're very excited for this opportunity. We felt now was a good time to go ahead and launch the center, because as we look forward to the future of environmental remediation challenges facing the nation, we recognize that as a community, we have some of the most complex challenges we've ever encountered ahead of us. So with this, we've gone ahead to launch the Center for Remediation of Complex Sites to help raise awareness of the activities that we have going on, the capabilities, and to allow greater leveraging of the work that we have in progress, and help facilitate continuity in the scientific and technical expertise available and that we can provide, both ourselves as well as that of our partners in the remediation of complex sites. So, as many of you know, as many of you on this call know, complex sites can be defined in many different ways. And there's been a number of studies that have been done over the last decade about complex sites across the United States. And they range anywhere from tens of thousands of sites to hundreds of thousands of sites, and hundreds of billions of dollars to remediate. This is a significant national challenge, and it's one of the largest liabilities that we as a nation face. Now, a complex site could be something as complex as the Hanford site here in Washington State, which is arguably one of the most complex sites in the entire United States, but it also doesn't have to be at that particular magnitude. A complex site can be much smaller than that. It can be defined by extensive groundwater contamination, heterogeneous geology. It could have multiple releases and many source zones. It could have commingled plumes. It doesn't have to have all of these different attributes to be a complex site. It could also be that the remediation progress and timeline for a particular site is one that has such uncertainty associated with it that it does not seem that it could be achieved in a reasonable time frame. All of these different aspects can contribute to a site being complex. And as the Department of Energy and the Department of Defense have made significant financial investments over the past several decades addressing these challenges. As we've realized in the last several years, the application of the traditional remediation approaches that have addressed a number of the sites across the country to this point have been met with mixed success as we've entered into these more complex sites. And it's underscored the continued need for advances not only in technology, but also in just remediation strategies, and also supporting the defining and achieving of risk-based end states for these complex sites. Through PNNL's history of supporting predominantly the Hanford site within the DOE complex over the last 50 years, we're very familiar with being able to support the regulatory framework that's necessary and enable the success of our industry partners and our federal sponsors in addressing such complexities. Whether it's establishing conceptual site models for commingled plumes, to defining what the nature and extent is of those contaminants and how that feeds into defining, perhaps developing, or maybe just optimizing existing remedial technologies to be able to provide options to be able to address these technical challenges. Or whether it's developing systems-based monitoring, PNNL has had a long history in both the leadership nationally through programs such as DOE, Department of Defense, the Interstate Technology Regulatory Council, and EPA, as well as internationally through the International Atomic Energy Agency. We've helped to develop many of the guidance documents at both the national and the international levels, and then we've helped to further refine those and make them actionable and something that can be implemented at a local scale. And so we thought that our history was one that we could really continue to help bring forward to the community and be able to share our expertise and our experiences and the tools and capabilities that we've developed and provide those as we have been to this point, but to perhaps a broader group of our industry partners and our federal sponsors to be able to address these significant challenges. So I mentioned that, we are located in Richland, Washington, and we are rooted deeply with our colleagues at the Hanford site. And the opportunities that we've had both at Hanford as well as across the DOE complex, the DOD complex and the sites that we've addressed there, as well as private sites and international sites. It's afforded PNNL the ability to develop a lot of capabilities and leadership in many of the dynamics that are associated with the complex sites that we face today. Whether it's understanding the coupled hydrogeologic and biogeochemical principles that are controlling the contaminants within those environments, or whether it's understanding that so that we can develop and optimize and implement technologies to be able to control those, building off of those natural processes, working with that natural environment to enhance those processes and mitigate the risk from those contaminants. Or whether it's developing systems-based monitoring approaches to be able to really understand the totality of these very complex systems and migrate away from looking at only point source monitoring variables, or whether it's towards the end of a site's life cycle, where we get to the point of actually being able to transition from an active remedy into a passive remedy. We've developed a number of exit strategies around many of the key types of active remediation, such as soil vapor extraction and pump and treat, to enable the community to be able to utilize that guidance and go terminate those types of active remediation activities, reducing those long-time mortgage costs and move into a long-term adaptive management. We do all of this in partnership with the site owners and our industry partners. As a national laboratory, it is not our responsibility to own these sites, to remediate these sites. We're simply here to provide knowledge, understanding, and tools to help enable the success of the broader community. We work on understanding what the processes are that are controlling those contaminants and how a remediation option may work within a certain environment. But ultimately, it's a handshake and it's a partnership that we work with our cleanup contractor partners to be able to transition that knowledge and those tools into actual implementation. They're the ones that are able to go off and implement that, and we're here to support the success in that implementation. That is key to us being able to continue to support these national challenges. But more than that, we also, as a very large multi-program national laboratory, have the ability to work across the multitude of federal sponsors who are faced with very similar challenges. In supporting Department of Energy, Department of Defense, Environmental Protection Agency, as well as our private international sponsors, we're able to take that scientific basis and leverage across the variety of different programs that we support to be able to advance from concept all the way through solution. We are able to overcome the traditional valley of death, if you will, for technologies, and the cost is one that then gets shared across that. No single entity has to pay for all of the effort that is necessary to go into the development of some of these very long time frames that are required to go from concept to technology. And then we make them readily available. So just a couple of examples. So the exit strategy for soil vapor extraction. We've been working on those types of systems for over 30 years. About 10 years ago, we started working with the EPA, the Department of Energy, and the Department of Defense to develop an exit strategy to get out of those systems. We developed a guidance document that all three agencies have been able to carry forward, and we provided the tools out to industry to be able to go implement this approach to be able to terminate those systems. We've done the same thing for pump and treat at this point. Or whether it's advancing real-time monitoring, developing advanced geophysical methodologies to be able to image in real time subsurface environments, not only to characterize them, but to actually watch remediation take place in real time, provide that feedback, and enable site owners and implementers to make real-time changes to engineered remediation to get the outcome that's desired. Here's just an example of that. Many of you are very familiar with this. This is a technology that we have readily available, both through the website at the bottom as well as links through our RemPlex website, which I'll talk more about in a minute. And it is readily available for anybody to be able to utilize. On the left, what we're showing is, this is an image of the Hanford site in the 300 area, and it's the influence of the Columbia River on the groundwater and what that does to the migration of uranium within that area. And on the right, we're looking at the real-time implementation of a polyphosphate technology that we helped to develop. And this is being injected into the 300 area and to stabilize the uranium that we were working to understand on the left. It's a technology that's now available and being broadly deployed, not only within the remediation community, but other communities where you need to see, if you will, within the subsurface. So I mentioned partnerships many times. Our partners are absolutely key to everything that we do. We are here to support, as I said, the remediation industry and our federal sponsors. There's many different ways to gain access to us. There's lots of different opportunities to work with us, to access the equipment that we have, to access the resources that we have. We have the Environmental Molecular Sciences Laboratory, which can provide everything down to atomic scale understanding if necessary, all the way to our pilot scale facilities and our actual field test sites where we can test in real time actual equipment out in the field. And so there's more information about our various partnership opportunities and ways to access our expertise and our capabilities on the RemPlex website. This is just a screenshot of that website. The address is there at the bottom, and you can find all kinds of information out here about how to work with us, the capabilities that we have, and we're also really trying to get raise the awareness of the activities that we have going on right now. We have lots of activities always in progress, and there's opportunity to leverage the fact that we are doing a number of activities on an ongoing basis. This real-time partnership and this real-time leveraging of the work that we're doing is what really enables the broader success of the community and the industry. Many of the problems that we're going to be faced with all have some level of commonality between them, and so if we can help facilitate that sharing of knowledge and that sharing of technology and that leveraging of resources and opportunities, we're very happy to be able to provide that service. In addition to just having awareness and understanding of some of the technical activities that we're doing at any point in time, we'll also be offering a number of different activities and resources to partake in. We're going to have a seminar series where we're going to communicate much of the knowledge and understanding that we have and that we're gaining through the projects that we're doing. We're hoping to transfer that knowledge and understanding to the other sites where it's of value. We're also going to be providing a number of trainings and short courses where you can gain more understanding of the tools and technologies that we have available on our website. And if you go to our website and you go under the resources, you'll be able to find a number of tools and technologies readily available for you to go ahead and download and or find out more information about where you can get further information. So we're looking forward to being able to continue to provide this service and interact with the environmental remediation community to be able to help facilitate the transfer of technology and the remediation of these challenging sites. So in summary, we're really excited about this. Again, we really appreciate you taking an interest in what it is the Center for Remediation of Complex Sites is going to provide. We're hoping to continue to provide solutions to these challenging problems. We're very excited about being able to continue the collaborations that we have, as well as help to expand collaborations and be able to facilitate greater collaboration between federal entities and private partnerships, and continue to be able to provide an independent technical resource as we address these challenging sites. So this is the leadership team. Many of you are very familiar with a number of these individuals, and with that, I think I will go ahead and open it up to questions. I believe Alicia will turn it back over to you to moderate that.
Great, thank you, Dawn. So we have over 100 participants today. Thank you everyone for coming. And we do have a few questions to start us off. So one question is, Dawn, can you provide some examples of tools or products that PNNL has produced or that are available through RemPlex for use in environmental remediation, and how can people access them?
Yeah, absolutely. That's a great question, and that's really kind of one of the keys of what we want to try to be able to do. So I showed a couple of examples. I touched on a couple of things. One of those is certainly the soil vapor extraction end state tool. So there's more information out there on that. And what this provides, it's really kind of a guidance document to allow the site owner and the remediation contractor to be able to think through what are the questions that are necessary to answer as you look to terminate a soil vapor extraction system, and be able to operate that system in a manner that allows you to collect the data necessary to be able to defend the termination of that system. It's a process that takes a bit of time, but it provides a well-aligned plan with the regulatory guidance to be able to do that in a very stepwise fashion and be able to get to that defensible endpoint. And that has been demonstrated and implemented at a number of sites. In the past, we've had specific webinars just on that tool that we've announced and shared through Clue-In, and I know we've had hundreds of site owners and site contractors download and start implementing that tool. So that one's out there. Another tool, one that I mentioned, was actually E4D. E4D is an advanced geophysical inversion code, and that is the horsepower, if you will, that allows us to take geophysical data sets. They could even be very large geophysical data sets, and be able to invert those in near real time and provide a view into the subsurface environment in terms of what is actually happening. And one of the things that we can do with that is we can actually partner with individuals and institutions to be able to utilize some of our high-performance computing resources to be able to help with that inversion. There's a number of other tools out there. We have some of our modeling tools out there which are fairly well known in the community, such as STOMP, and a number of other things that are out there. So I really encourage you to go check out the website. There's a lot of different tools that are out there. Most of them have links to how you can download them or get further information on all of those tools. And we'll continue to add to that as we develop things.
Excellent, thank you. Can you speak a little bit to the breadth of RemPlex? Is RemPlex mainly for radionuclide contamination, or can you just speak to kind of what is encompassed by RemPlex?
Right, absolutely. No, it is absolutely not only for radionuclides. Our experience, as I mentioned, yes, we have done a lot of work with radionuclides being located in close proximity to the Hanford site. But as I mentioned, we worked in a number of DOE sites, a number of DoD sites, as well as private and international sites. And so the types of contaminants that we're readily addressing at this point in time are everything from PFAS, PFOA contaminants to chlorinated solvents, to inorganics, to radionuclides. It really spans the entire breadth of potential contaminants. And again, depending on what level of capability is necessary, we have capabilities that can go anywhere from literally an atomic scale all the way through field scale operations.
Great, excellent. And just expanding on that question a little bit further, what kind of Earth system processes are included? Does RemPlex only focus on the subsurface?
So RemPlex is very much focused on the subsurface, but we do have experience, as I mentioned in one of the slides, with situations where we have surface water in near proximity and having surface water interactions that may influence subsurface processes in a contaminated site. So it's not rigidly limited to only the subsurface environment.
Great, thank you. Can you talk a little bit about some of the on-site capabilities at PNNL that can be accessed via RemPlex for use on an environmental project?
Absolutely. So I mentioned EMSL, which is our Environmental Molecular Sciences Laboratory. That is really, it is a DOE user facility. Some folks may be familiar with some of the other DOE user facilities, such as the large synchrotron facilities. This is PNNL's DOE user facility. It has a lot of high-end spectroscopic and microscopic equipment to really be able to look at surface interactions. And so it's been used quite extensively in the work that we've done in terms of understanding the processes that are controlling contaminants within a sedimentary environment. And then we've got capabilities that scale all the way up through laboratory, bench scales. We've got pilot scale facilities, and we've got large field sites. And we have everything available from being able to do batch tests, column tests, both with radiological materials as well as non-radiological materials. And then I also did just mention briefly in one of my examples the fact that we do have a number of HPC resources. We have a supercomputer which we utilize actually quite readily when we're processing these large environmental data sets which generate a tremendous amount of data. The geophysical surveys that we do is one example of that. And we actually have set up a lot of that capability to be able to be done remotely, autonomously. So it takes very little engagement, and we're able to just provide the information and the understanding about particular sites and particular challenges that one may be experiencing.
Great, thank you. Do you see any role for material scientists in RemPlex? If yes, what is the best way to participate? Oh,
absolutely. We both from the perspective of just understanding the solid phase environment that we work in, the sedimentary environment that we work in, how the contaminants interact there, all the way to developing specific materials of interest. So part of what we also do is we actually do utilize the material scientists at PNNL to be able to develop new materials that will help specifically target contaminants of concern. For example, one area we're doing that in right now is that of PFAS. It's an extremely difficult set of compounds to be able to address, and we have a broad history in actually dealing with perfluorinated compounds for a variety of other reasons. So building upon that knowledge, we've been able to develop some new compounds that can specifically target the various PFAS compounds, the parents as well as the degradation compounds. So there's absolutely room for materials scientists in supporting REM-Plex and environmental remediation generally. And I would say to get involved, feel free to contact anybody on the REM-Plex leadership team, or just send an email to the remplex@pnnl.gov that's there on the screen.
Excellent, thank you. Another question related to CFD. So is there any scope of computational fluid dynamics work related to surface flow in RemPlex?
We actually do have quite a lot of CFD work and modeling work. I did mention STOMP, which is predominantly a subsurface one, but yes, the flow and transport is a cornerstone process to be able to understand the fate and behavior and transport of contaminants within the environment. I don't think there's probably, I would be hard pressed to say if we've ever done a project where CFD modeling has not been a component of that. And I'm going to check right now real quick to see if Vicki Friedman, who's part of the RemPlex leadership team, happens to be joining us today. She's one of our leading experts in modeling, and see if she would like to add anything to that. Are you on, Vicki? Nope, I guess not.
I'm on. Am I still muted?
Oh, there you go. Nope, we can hear you.
You can hear me? Yeah, I think I'm guessing that the CFD is perhaps more related to surface water. I don't know if we can get some clarification on that, but I agree with Dawn that there definitely is opportunities for that. Some of the work that Tim Scheibe has done here at the lab has coupled CFD modeling with subsurface transport modeling as well. So I guess I would just second what Dawn had said with respect to CFD modeling.
Excellent, thank you. A couple more questions here. Someone mentioned that they had worked in the 300 area and was wondering if you could talk a little bit about the extent of contamination and maybe PNNL's role in evaluating the extent of contamination of uranium in the 300 area.
So PNNL has a long history in studying uranium in the 300 area. That's something that, again, goes back to kind of the leveraging across programs. We've worked on that problem both with the Department of Energy Office of Environmental Management as well as the Office of Science. It's a problem that we have been involved with for quite literally probably 30 years, if not a little bit longer. So we started way back at the beginning of that in just terms of trying to characterize that site. And so we did the initial characterization. We helped to define the initial record of decision. This is the short version. We helped to define the initial record of decision. We supported the monitoring and the long-term assessment of how that record of decision was performing. As happens in many sites, especially complex sites that they're being remediated. As you pick a remediation option and you start to go forward, you continue to learn about that site. And we continued to learn that it was more complex than was originally thought 30 years ago. And it has a very interesting disposal history from going from very acidic to very basic waste streams. And the uranium within that site had actually migrated into interstitial pore space within a lot of the sedimentary materials, and it had also laterally distributed in a very significant area within the 300 area. And one individual once described it as it's kind of a ring around your bathtub, and that was actually a very appropriate description. And so we utilized that understanding to then develop a new type of remediation approach that would be able to better address that ring around the bathtub and be able to infiltrate into those interstitial pore spaces to be able to stabilize that uranium in place. That is the record of decision that is currently being implemented at this point in time, and seems to be working fairly well. The one ERT image that I had shown was actually that exact implementation. And so right now it's been implemented, and we're kind of in that 5-year monitor and review and assess and adjust as needed.
Great, thank you. I'm going to combine a couple questions into one larger question since they're very similar. Talking about funding and coordinating and collaborating, can you talk a little bit about PNNL partnering with PNNL on proposals for environmental work? What are the mechanisms to do that? And specifically, does RemPlex provide any funding opportunities, or is the main opportunity here to be a partner and to collaborate?
So RemPlex itself does not provide funding opportunities. The main emphasis is for us to be able to help better provide our technologies, provide access to those technologies, to be able to provide awareness of the work that we are doing, and when and where it makes sense to be able to leverage that ongoing work. Many of the projects that we work on provide understanding of the environments and the various contaminants that do have a level of ability to translate to other sites. And so it's really to provide a mechanism to transfer that scientific understanding and the technologies that we're in the process of advancing to others that can benefit for it. In terms of how to partner with us and whether or not we can partner on proposals, it all depends on how the proposal is, or how the RFP is written. We are a federally funded research and development center. We do not compete with industry, and so in some situations there may be an RFP that's released that has very specific wording that would prohibit us from being able to be a named partner and compete. We do not want to compete against our industry partners. So if that is the situation and an award is made, if there's a capability that we have that the awardee finds would be very beneficial to them, you could also come back to us after the fact. At that point in time, you could access us, and you could access the capabilities that we have to be able to support you. If it's an RFP that does not have any restrictions for an FFRDC participating, we can participate on a proposal just like anybody else could participate on a proposal.
Excellent, thank you. So one final question. Do you see a role for environmental scientists when it comes to remediation in challenging environments? And if so, how does one get involved?
Oh, absolutely. Environmental scientists are probably at the core of many of the capabilities that we have within RemPlex. So again, just like I mentioned for the materials scientists, contact us, talk to the leadership team, send an email to the RemPlex inbox, and we will be glad to have follow-up conversations with you about your particular skills, expertise, and how to get involved.
Excellent. Thank you, Dawn. So with that, I'd like to thank everyone for joining our webinar today. Just a reminder that the webinar will be archived on the RemPlex website. We look forward to presenting our next webinar on uranium behavior in the subsurface on June 18th. More information on the June webinar is available on the RemPlex website. And we also encourage you to sign up for the newsletter by sending us an email to remplex@pnnl.gov. So thanks again, and stay safe.